You're listening to the Security Matters podcast. I'm David Puner, a senior editorial manager at CyberArk, the global leader in identity security. It's a scenario that's becoming all too common. You're the cybersecurity lead at a major enterprise. One morning, your team discovers a single API key leaked on GitHub, months old, never rotated, and still valid. Within hours, attackers slip inside your environment, not through a human password, but through a forgotten machine credential. And with machine identities now outnumbering humans by more than 80 to 1, that single key isn't just a crack in the door, it's a superhighway across workloads, containers, and AI agents powering your business. This is today's frontline. Secrets sprawling unchecked, workloads multiplying faster than security teams can control, and even the most seasoned experts struggling to keep pace. To help us make sense of this shifting identity landscape, today I'm joined by Matt Barker, Vice President and Global Head of Workload Identity Architecture at CyberArk. Matt co-founded Jetstack, created the open source standard Cert Manager, and now leads CyberArk's efforts to secure workload and machine identity at scale. Let's do this. Here's my conversation with Matt Barker. Matt Barker, Vice President and Global Head of Workload Identity Architecture at CyberArk. Welcome to the podcast, Matt.
Thank you for having me. Pleasure to be here.
Absolutely. Where are you today?
I am in central London, a place called Kensal Rise. If anyone has watched the movie Notting Hill, I'm about 10 minutes walk from there.
We are excited to have you here. So let's start things off with a quick career dive. In the last 10 years, you co-founded Jetstack and created Cert Manager. Now you're leading workload identity initiatives here at CyberArk. It seems like a bit of a whirlwind. How'd you get to where you are today being the pinnacle, a guest on the Security Matters podcast?
Yeah, I mean, pure luck, but obviously this is what I've been working towards, to be here on this podcast, as you know. But in all seriousness, yeah, it's a bit of a strange start because I actually began my career selling books door to door. It just so happened that I managed to break the sales record of a director for a small startup in the UK called Canonical, which created an operating system called Ubuntu. And Ubuntu grew to become essentially the operating system of the cloud. And so it was really just by chance that I got into open source, although I was kind of interested in getting into software technology because I kind of thought that's where the future might lie.
Yeah.
And then since then, it's just been me looking for various different ways of trying to pick an area that I thought was interesting and one that might have a bit of growth potential. And so I went from Linux to NoSQL with MongoDB. I was a very early employee of MongoDB. And then I saw the growth of containers and then the open sourcing of Kubernetes. And I felt so strongly about that I thought I had to start a company around it. And that's where Jetstack came from.
What inspired you to focus on workload identity and machine identity security? Are there any pivotal moments in your career that shaped your approach to cloud native security?
Well, I didn't mean to get into cloud native security at all. I desperately wanted to get into cloud native, but I didn't want to get into cloud native security. I saw security as the domain of people that always told me no, and I couldn't do that project with Linux or NoSQL or open source or MongoDB or whatever it happened to be. What I was really interested in was the open sourcing of Docker and the container standard. And then my thoughts that if containers were used extensively, you might have thousands, if not millions, if not billions of containers to run. How do you actually manage and organize all those containers? And so when Google came about and open sourced their internal orchestrator, which is called Borg, as Kubernetes, I was blown away because back in 2014, they were starting and stopping 2 billion containers a week. So if you think that every time you spin up Gmail, it's in a container being orchestrated by Kubernetes. And I thought if that's what ends up happening for the rest of the world of IT, then there's going to be a lot of requirements and demand around Kubernetes and all of the services that go around that. So starting Jetstack was literally just to try and help people to use Kubernetes and understand how to scale it and build it properly. But in the process, we realized that there were lots of gaps in how people thought about securing Kubernetes. And so really, just by chance, actually, we decided to focus specifically on certificate management within that. And it was an engineer's interview project to automate certificates inside Kubernetes. He did that over a weekend, came back to us on the Monday. We gave him the job. And then when he joined us a month later, we decided to open source it. And relatively quickly, it grew to become the de facto standard for the way that you think about managing and automating certificates in Kubernetes. But it was never something that we set out to do.
Cert Manager is still getting millions of downloads a day. Is that right? And I assume with AI on the rise, it's probably even growing on a daily basis.
Yeah, so Christian was the guy that originally started it with a project called KubeLego. We relaunched it as Cert Manager. So originally it was just specifically for Let's Encrypt, and then we made it CA agnostic. But James Munley, who was one of our early engineers, took on that project and relaunched it as Cert Manager. He sent me some recent stats on it that said that it's downloaded 18 billion times a year. So that's quite phenomenal when you look at the amount of data that takes and how often that gets downloaded. But I would say subjectively, from my conversations with enterprises and banks and retailers and so on, every Kubernetes cluster that they have more than likely is going to have Cert Manager in it. So I'd say it's in 8 or 9 out of every 10 Kubernetes clusters. I don't foresee that download number slowing down. And it's certainly one of the first cluster add-ons that you would add to Kubernetes once you've installed Kubernetes itself.
You're the global head of workload identity architecture here at CyberArk. You've already mentioned the word workload a few times. Let's level set here at the beginning of the conversation. Workload and workload identity, what is it? And why is it such a critical concept in today's IT environments?
So for the past 20, 30 years, we've thought very hard and long about how we secure humans and human access to systems inside our organization. So if you think about your corporate network, you have 2 actors on it. And the first one that we always think about are the human actors on the network. But then the other actor on the network are machines. So you can think about a machine, in my mind, in 2 categories. So you have physical machines. So you have a laptop or a server or a cell phone, and that connects to your network. But you also have another category of machine, which is what we call a workload. And a workload is essentially a piece of software that runs on that machine and connects to another piece of software. So you could think about it as a container or a virtual machine or a Kubernetes cluster or a serverless function. And so as these workloads explode, one of the foundational ways that we think about securing those machines is using certificates and public key infrastructure, or PKI. And so what was really amazing about creating Cert Manager for Kubernetes is it put us in this really tremendous position in the center of this ecosystem of machine identity. Not that I really knew it at the time. And so we developed a partnership with Venafi specifically because they had a lot of customers that were trying to secure traditional on-premise data center machines using the Venafi suite essentially to automate, manage, and rotate those certificates.
Venafi, the company, has, of course, since been acquired by CyberArk, and here you are.
Yeah. And they had a lot of those customers that were trying to connect those machines and use Kubernetes in the cloud. And so essentially we created a connector between Cert Manager and the Venafi suite. And it was at that moment that I started to realize, thanks to speaking to them, that I think the rise of machines was going to happen. And the way that we thought about protecting and securing those machines was going to get more and more important, just because it's something we'd ignored. We thought a lot about securing humans on the network, but we hadn't thought as much about securing machines. And so when Venafi came along and said, would you like to be acquired by us? To me, it made complete sense, because I was like, this is where essentially the future of protecting our organizations will go, because machines, to a certain extent, are probably going to outweigh the number of humans there are inside the company. And if AI ends up becoming as important as we think it does and becomes a little bit more autonomous and agents actually do become a thing, then hackers are likely going to take advantage of those. And so it's probably a good bet to think about securing machines as being the next frontier of how we secure an enterprise. And this was also at a time when the network was being completely and utterly obliterated, because we used to put a firewall around our network and we used to secure the perimeter. Whereas like when you're in COVID and you've got a personal laptop connecting to a corporate network, how can you trust that machine? How can you trust that person? And so that meant breaking down the perimeter and thinking more about the individual machine itself and thinking, or the workload, and thinking about how we secured that rather than just keeping everything hoarded and protected inside our castle wall, as it were.
So talking a lot about machine identities and the explosive growth and how they now outnumber human identities by more than 80 to 1. What's driving this explosion, and how does it tie back to workloads, and why is it such a challenge for security teams?
To start with what's driving it, we talk a lot about volume, velocity, and variety of workloads. So I would say I'm partly the problem for the growth of workloads, because by enabling people to adopt cloud native technologies, which means microservices architecture, it means public cloud with ultimate scale, it means containers, it means functions and serverless, you've basically got a huge amount of consumption and growth in cloud native workloads and use cases. So it was growing fast already. So, I mean, it was only a few years that we were talking about 20 to 1 for machine identities to humans. Then it was 45 to 1. In the past year or so, it's gone to 82 to 1. And I think that's partly down to the number of AI agents, because we're sort of starting to unleash a swarm of AI agents. And each one of those agents needs to have an identity as well. And so this is not going to slow down. I mean, I don't know how many workload identities we're going to be talking to as a ratio to human identities in the next 5 years, but I can imagine it's going to be pretty significantly higher than 82 to 1, which already sounds quite high to me. And then I think the next huge acceleration in the number of workloads and workload identities is going to come from AI agents and everything that entails.
So how does workload identity help secure AI agents, and what risks do they pose if not properly managed?
So at this point, we have to think about how you actually secure a workload itself and what identity means to that workload. So most of the way that we think about securing our machines is kind of similar to the way that we thought about securing our human identities, which is with the equivalent of usernames and passwords. And we refer to them collectively as secrets, whether it's API keys or service accounts or personal access tokens, whatever it tends to be. So we collectively refer to those as secrets. And you put all of those secrets in a secret store. And every time that workload needs to get access to some other third party, it will go and retrieve that secret and use it. The problem with secrets is that they are hard to manage, hard to rotate. They get spun up and used in various different places that the organization doesn't know where it's being used. They get shared on Slack. They get hard-coded in and unfortunately leaked, and they end up on GitHub. Mm-hmm. So secrets are everywhere, and they are very hard to manage, control, and secure and protect. And so what I'm thinking about doing is essentially extending all the work that we've done with PKI and certificate lifecycle management, and essentially build on top of those foundational pieces that we've got. And rather than using a secret to secure access to a workload, we'll actually apply an identity, an open standard identity to the workload as it's born. And we'll end up using the attributes of the workload so that we can trust it. And then we'll use the identity to secure access to another workload. So rather than having to think about managing and all these different secrets and run the risk of leaking them, you can actually just trust that the identity of the workload can talk to another workload by the inherent identifiers or markers that workload has. And so like once you've trusted the workload, you've attributed it, you make sure that you understand it and register it, and you trust it, it can go off and do what it wants, but then you apply an identity to it and you use the identity to secure access rather than a secret.
You've described the current state of machine-to-machine communications as identity hell, and that's driven by secret sprawl, as you were just getting into a little bit there. What do you mean by that, and why are traditional secrets-based approaches no longer sustainable?
If you're someone who has to manage your username and passwords for the number of logins that you have for all your websites or your email account, for example, think about a machine that has to talk to 100 different services inside an organization. If you think about the number of equivalent passwords that it has to remember and use at the right time, you have to make sure that they're rotated correctly. It's a lot of manual effort, and a lot of these secret stores get used as kind of dumping grounds. And like I said earlier, they end up getting hard-coded and often shared on Slack and then inadvertently leaked.
Right.
So now if you think about the number of machines increasing day by day, so we've gone from 40 to 1 to 80 to 1, maybe that could be a couple hundred to 1. And then you multiply that by the number of different environments that it has to run across, all of whom have slightly different ways of thinking about identifying and securing access to the workload. And then you think about some of the autonomy that comes in with AI agents. The actual process and amount of work that's going to go into thinking about securing workload A that's in an on-premise data center environment to workload B that could be in Amazon cloud, but next week it could be speaking to another workload that's in Google Cloud. And remember, these are AI agentic use cases in some instances, which means that that agent's going to want to go and talk to any of your environments or potentially any of your workloads or any of your services at any time. Think about the manual effort that goes into that and the amount of secrets that already get leaked, like in the situation that we're in now. If you increase the intensity or the number of workloads and you increase the demand for access to all these different services, it just becomes almost impossible to think how you would actually go about and do that. And I think most organizations and individuals inside an organization have what one colleague refers to as almost Stockholm syndrome. They just use secrets because that's what they use. They don't know what else they could be doing with it. And it just becomes part of their day-to-day like process or work to create the secret, put it in a secret store and go back and then access the secret store to go and get the secret to then secure the workload. What I'm proposing that we do is we radically improve and change the developer experience by using the identity of the workload itself to secure access to those workloads. And it doesn't matter, again, whether it's in a data center, in a VMware environment, or it's an S3 bucket in an Amazon cloud. We should find a way to apply universal identity that's consistent across all those environments. We should try and limit the amount of times we need to use a secret to secure those workloads. And we should start to use the identity of the workload itself to secure access between them.
We've seen incidents like the 2024 U.S. Treasury breach where a compromised machine identity and API key in that case was exploited. How do these events highlight the vulnerabilities of secrets-based security models, and what lessons can security leaders take from it?
So shout out to our partner GitGuardian. They do an annual State of Secret Sprawl report, and they said that on GitHub they found 24 million leaked secrets. And that was up from something like 17 million secrets the year before. So we're growing at a rate of 25% year on year. Mm-hmm. And they go back and check those secrets. And more often than not, they're still valid 2 years later. So they're just sitting out there. And so if you're a hacker who wants to try and get access to a corporate network, you could go and try and spearfish some person in the support team, which might be a valid way of doing it. Or you could just go to GitHub, find a leaked API key or whatever it is, do a bit of work and find your way into the corporate network. And that's what's happened with these hacks that we're seeing almost week in, week out. I was speaking to the ex-CISO of a large telco in Europe, and he now does some consultancy for a bunch of CISOs across Europe. And he refers to all of these leaked secrets on GitHub as almost being like a buffet for hackers. They could just go pick their secret and do a bit of work, and before you know it, they're inside your systems. And so I think most organizations don't realize just how bad and how big of a problem this is. There's been a lot of buzz around the non-human identity space. So this is a lot of startups that essentially gained a lot of traction by going and scanning your environments to see where all these machine identities are and try to understand them, who has access to them, what they're being used for, and then essentially give you a risk profile and a context of what that machine identity is doing or that non-human identity is doing. But that's only half the problem. Like, obviously, you need to discover all those secrets, but then you also need to think about how you reduce the number of them, and then potentially thinking about reducing the number of secrets. Instead of using secrets, you can then use something else like SPIFFE. Mm-hmm. But yeah, it's just growing to become a really, really scary, horrible problem. Again, the State of Secrets report also said that you're 40% more likely to leak a secret if you're using AI-generated code. When we start unleashing AI agents and a bunch of business analysts who are using Replit or Bolt or Lovable to create new applications, there's probably going to be a whole bunch more of them that get leaked.
So let's talk about SPIFFE for a minute. The Secure Production Identity Framework for Everyone.
Yes.
That's the longer name, which is quite a name. It seems to be a cornerstone of workload identity. Mm-hmm. So what is it, and why is it gaining traction among major cloud providers and enterprises?
SPIFFE has been around for quite a long time. I'm saying maybe around 2016. What most people don't know is that SPIFFE was created by the same guy that created Kubernetes. And so it's actually from the same mind, as it were. And obviously, for those of you that don't know, Kubernetes was an open sourcing of the internal orchestrator that Google ran called Borg. SPIFFE essentially is an open sourcing of the identity framework that they had inside Google called LOAS. I hope I've not got that wrong. And my thinking was that when Kubernetes was open source, most people would be worried about thinking how they're going to build and run their cloud native architecture on Kubernetes. And if it became successful, then you're going to have billions, if not trillions, of containers running in multiple cloud environments. And at some point, you're going to have to think about securing them. So when SPIFFE came out, I was quite excited, thinking, oh, this will be something that we end up applying or using to sort of secure all those different workloads. As it turns out, we didn't. And not much has actually happened with the SPIFFE project up until more recently. I think most people were more focused on building the compute and standing up the use cases. And honestly, collectively, it feels like the cloud native community and ecosystem was mainly focused on just building the stuff for the first 7 or 8 years. It's only in the past couple of years that we've really thought about securing it. And so SPIFFE is essentially an identity standard, and it was donated to the CNCF. So it's actually a graduated project as part of the CNCF in the same way that Cert Manager, our project, was donated to the CNCF and is a graduated project. And what it enables you to do is it gives you a universal identity standard. So every time you spin up a workload, it has this concept of an SVID or a SPIFFE verifiable identity. And you can figure out how to consistently name a workload so that it becomes unique and then universal. So every time you spin up a workload, it gets its own identity. And SPIFFE essentially is the identity standard or type that you apply to that workload. And once you've registered your workloads and they've got their SPIFFE identity, you can start to trust that workload and that identity. And that SPIFFE identity is actually built on top of what you're already doing with your certificates and your PKI infrastructure. So it means you don't have to go and learn this whole new thing or implement this whole new system for SPIFFE. You can use what exists inside your organization, which is a pre-existing PKI infrastructure. So what we're saying is essentially go and apply that SPIFFE identity and use that identity to secure access. And if you can't use the identity, then use a secret, because we realized that you can't just go and replace all of your applications and give SPIFFE that easily to all of them on day one. But over time, by applying a SPIFFE identity and using that to secure access rather than a secret, the portion of workloads that you're securing using identity will increase and the number of workloads that you're securing with a secret goes down. But ideally, you want to give the option to do either, which is why we've created this new solution, the Secure Workload Access solution. You asked a little bit about why it's picking up momentum now. I think it's because of these hacks. There's a lot of talk around zero trust and the CISO framework for that. And obviously now we're at a point where cloud native has become so successful and there's so many workloads running all over the place. And there's so many platform engineers that have gone out and built all these containers and Kubernetes architectures with so many workloads all over the place where most organizations don't really know where they all are and what they're doing. I think everyone's just sort of standing still and thinking, oh my word, we need to understand where all our workloads are. We need to understand all of their identities. We need to give some context to those identities, understand the risk profile. We need to try and reduce the number of workload identities we've got. And then we need to think about a really consistent, strong way of applying identities so we can use that to secure these workloads going forward. And I think it's really a matter of timing.
So zero trust, workload identity is a key enabler of zero trust architecture. So how does it help organizations implement zero trust, and why is the alignment so critical for security leaders?
The fundamental concept around zero trust is that you never trust, you always verify.
Mm-hmm.
And so essentially when it comes down to what I was talking about earlier, where the perimeter of the organization is now gone, and you've probably got a workload that you're spinning up, and it used to be inside your data center and it used to live inside the firewall. Now that's somewhere in the cloud or it's somewhere on someone's laptop at home. Zero trust is like a very confused concept and it's a little bit of a buzzword. And I feel like I can ask 10 different people as to what zero trust means and I get 10 different answers.
Right.
What I always end up going back to is the CISO, the Cybersecurity and Infrastructure Security Agency. So it's a government department. And there was actually a mandate by Biden a couple of years ago that all agencies inside the US should start to implement a zero trust strategy. And CISO essentially created that zero trust framework and strategy. This is like a strategy house and there's various different pillars and it's all underpinned by governance and observability and so on. But the first pillar of that strategy house is identity. And so identity essentially is fundamental to the way that you think about securing your machines or your workloads. And so identity doesn't cover everything, but identity can be applied to so many of those other pillars on there. I think it includes things like devices, networks, applications, workloads, and data. So one of the best things about SPIFFE is that it's consistent, it's universal, and it can be applied to any of your workloads. And you start to use that to essentially register attest, and understand where all your workloads are.
How are compliance requirements influencing the adoption of workload identity solutions?
I would say that compliance is not the major reason that people come to us to talk about or think about adopting workload identity. I think the major reason people come and speak to us about applying and using workload identity is they realize that they have a problem where they don't know where all their workloads are and they don't know where all their workload identities are. They don't know who has access to them. They don't know how risky they are. They don't know if they've been leaked. And so they realize that they have a problem. And they need to think about essentially understanding where all those workloads are, understanding where all those workload identities are, and then thinking about something that's going to make things better for them going forward. So that's probably the number one reason. It's them seeing the Department of the Treasury attack and understanding that just one leaked secret can cause tremendous damage. And it's the threat of that, I think, is probably the number one reason. I think the other reason is inconsistency. I think they realize that we're now in a multi-cloud world and all these different cloud environments have a different way of thinking about identifying and securing workloads. And so rather than having like 5 different ways of doing it and having to manage 5 different ways of securing workloads or identities, they want one way of doing it. So they want this concept of a universal identity standard or identity as a service. Some people refer to it as. The other thing that they're coming and talking to me about is the challenges and the difficulties of securing or connecting securely a workload that's in an on-premise data center to a cloud workload. Because in the data center, there's not a particularly good fundamental concept of identity. So they want to adopt SPIFFE to apply an identity to your machines inside the data center and then use that to secure access to cloud. And then it's also something called the secret zero problem. And so secret zero refers to essentially, I think of it as like the master key. So if you create a secret store and you put all your secrets in it, you have to have a master key, like a master secret to enter the secret store. So where do you put that? Well, you probably have to put it in another secret store. And then where do you put the master key for that? Well, in another secret store. And this is why you'll see a lot of reference in the workload identity community to turtles, because essentially it's like turtles all the way down. Because in, I think it was Hitchhiker's Guide to the Galaxy, there was the turtle that carried the earth on its back. But who carried the turtle? Well, it was another turtle. And then it was essentially turtles all the way down.
Uh-huh.
If you want to read the book on SPIFFE, it's actually referred to as solving the bottom turtle problem, which I relate to as a secret zero. And that's why turtles show up.
How is that book? Is it a good read?
Yeah. I'm sure you'll love to read that on a Friday evening with a nice glass of port or whatever it is you drink.
All right. Yeah, sounds good. I just wanted to get back to community and a point that we were sort of on earlier, which is how do you see Cert Manager and SPIFFE adapting to support identity for autonomous systems? And what role does open source play in keeping those systems secure and interoperable?
So I'm assuming they're AI agents. So I like to think of an AI agent essentially as a workload. So we talked before as a workload being a piece of software that talks to another piece of software. So therefore, you should just apply a SPIFFE identity to it and register it and attest it and actually think about it in the same way as you would think about any other workload in your environment. So that's the first thing. I think the second thing about a workload that is an AI agent is the AI agent then is going to go off and start talking to third-party systems on your behalf. And it has attributes that make it similar to a human in the way that it wants to access Salesforce or Jira or whatever else it is. Now, that to me is a different problem to solve, and that's more on the human side. And so what's going to be interesting in how we evolve AI agents and workload identity is how workload identity plays off with the human side of what an AI agent needs to do. And that's where there's a lot of discussion and talk in the community around how we best support and enable those AI agents to talk securely to those systems. And it's been really fascinating to see all the various different vendors coalesce and get together to try and solve this. Firstly, through the IETF working groups. And so specifically one that we're involved in is the Whimsy working group, but also at places like my workload identity event, Day Zero, which I run around KubeCon twice a year in Europe and in North America. So there's always a lot of talks about how we actually solve this. And what's great about where that's going is that I think the industry is, the identity industry at least, is starting to coalesce around using SPIFFE for the identity of the AI agent itself. But then we're likely going to use various other pre-existing identity standards to do the human side. So OAuth is one that's rapidly becoming a standard for that. And so I think the combination of these open standards together with all of the different value that the vendors can add on top of that, I think essentially will end up being the way that we think about securing AI agents.
Yeah, so you speak regularly about AI regulation and open source. What do you think are the most exciting or concerning developments in AI right now, especially as they relate to identity and trust in machine-to-machine communication?
The thing that is quite exciting to me is that obviously the big foundation models and the really famous ones are all proprietary. So you think about ChatGPT, you think about Gemini or Claude, and they come out of these huge multi-billion-dollar funded proprietary organizations. But then it was only, 4 or 5 months ago that we had the DeepSeek moment where we realized that a bunch of Chinese researchers had created a fully open source model that was almost as good, 90% as good as some of these tremendously expensive foundation models. And so what I find really fascinating about the AI market and ecosystem is that a lot of the models that are being used right now are proprietary and foundational, but I don't think you can ever write off open source. And my hypothesis a few years ago was that you're going to end up with like a huge long tail of open source models that will get used for specific purposes inside the enterprise. So DeepSeek was one of them, but then obviously you've got Llama from Facebook that was open sourced. Qwen is another one, another Chinese model that's very, very strong. And so I think as an open source guy, it's really fascinating to see the interaction between open source models and the progress and development of those versus the big foundational proprietary models. I think I'm particularly worried about the leakage of data and the interaction of the application of certain models on customer or organizational data, the potential risk of models being poisoned, secrets being leaked, all the usual stuff, and then potentially AI being used by bad actors to sort of increase the sort of attacks on organizations. So it just increases the threat and challenge we have with securing and protecting all of those workloads and machines inside an organization. A lot of companies that I speak to are already quite rational about this and they're quite discerning about it. So they're not just sticking everything in some public model online. They already have quite stringent regulations and guidelines around the way that their employees can use this AI. And I feel like I'm seeing a lot more of an adoption of on-premise AI use cases. So not everything has to go to ChatGPT. I'm seeing companies go and buy their own GPUs or build their own AI platforms from open source components and actually keep their data a bit more protected and close to home in their own data center and then apply AI locally rather than thinking about just sending it to the cloud. So I think people are starting to realize a lot more that, how valuable and important the data is, because obviously the data is what creates these incredible models. And so they realize how valuable it is to these software companies that want to use it to train the next model. And so that becomes competitive advantage or your most prized asset. And so I think it's the dynamics between speed of adoption, open source, proprietary, like the potential threat from bad actors on using AI, and how essentially we're all in this sort of like race.
Mm-hmm.
You have to kind of balance the adoption of AI with the security of it. And I think it's just the dynamics around that I'm finding so interesting at the moment. It feels almost like we're at the beginning of like this whole brand new movement, and this could be the foundation of like the IT industry for the next 50 years, for example. And it feels a little bit like what I saw with Linux 20 years ago, and then, in a smaller way, NoSQL 5-10 years later, and then the public cloud a bit after that, and then with Kubernetes and containers. It's like I feel like we're certainly at the beginning of the age of the AI agents.
So then for organizations looking to adopt workload identity, where should they start? Are there specific high impact areas or quick wins they should focus on first?
You can't protect or secure what you don't know about. So I think that discovery and context piece is really important to begin with, understanding where your workloads are, what their identities look like, how risky they are, whether there are any potential issues with those. So I think first and foremost, you want to get a really good handle on that. And then once you've done that, I think you want to think about what I've been talking about, which is you're using workload identity as a way to secure access for workloads. I think it's not that easy. I did used to get quite a lot of criticism. It's like, it's going to take me years before my applications become SPIFFE aware. But I think the pressures that people are seeing from these attacks and the growth of workloads and the understanding that they don't want these long-lived credentials hanging around is kind of really accelerating the demand or the interest in actually testing this out. I think what maybe a lot of people don't realize is that they're already using cloud native projects or software like Istio, which is a service mesh. It's already got SPIFFE in it. So you're already using SPIFFE if you're using a service mesh. And so there are parts of the organization that might be really easy for you to go and use SPIFFE with in the short term. And so, yeah, you really want to go and identify the low-hanging fruit, which I know is a bit of a cliche to say, but like the easy parts where you can go and use workload identity instead of a secret. But I think it's really not a destination workload identity. It's really the journey of it. What you really should be doing is kind of figuring out how many workloads you've got, figuring out what all the identities look like, understanding the context of those and understanding the risk profiles, and then thinking to yourself, well, actually, there's that set of workloads that we could easily apply a workload identity to. So let's do it on those first. And for the rest of those workloads, let's just continue to use secrets. And then over time, slowly but surely, as the education inside the organization goes up and the methodologies and the tools become easier to use, before you know it, you could be increasing the number of workloads you secure with a workload identity. You could be like at 40, 50, 60% of your organization is using a workload identity rather than a secret, whereas today it might be zero. So like over time, the relative proportion between secrets and workloads to secure access is going to increase. And I think that's the way that a lot of my customers are thinking about this. They realize they're going to have to do something.
So as far as that goes, education, starting somewhere, moving away from secrets requires a mindset shift. So how can security leaders overcome resistance and get buy-in from their teams?
A good workload identity security solution should actually hugely speed up the way that you build and deploy software. If you do it correctly and you bring the right teams to sort of help build, manage, and deploy a workload identity solution, then every time that workload gets spun up, you know that you can trust it straight away. So actually the developer experience becomes much easier because you don't have to mess around with secrets. You don't have to think about them. You know that you can trust that workload. So yeah, there's a huge incentive from like the board or from the CISO to think about reducing the number of secrets they're using a workload identity, just because it makes them more secure and it makes them easier to sort of get a handle of their workload identities. But you can actually go and sell it to your development teams or your platform engineers on the fact that if you adopt this, that it should really speed you up and it should make things much easier when it comes to going deploying and building and managing all the workloads in your organizations if you do it right. And the amazing thing about CyberArk is that we already have a secrets manager. So I'm not saying replace your secrets manager. I'm not saying we can get rid of secrets overnight. What I'm saying is keep hold of that existing secrets manager and we'll just give you the option of applying a workload identity to that workload as and where you can. And so you get a choice then.
A hybrid approach.
Yeah, it's very much a hybrid approach. And so we're really trying to meet customers where they are and be really pragmatic in the way they think about this because we know it takes time. But I'm also incredibly incentivized and hugely passionate about wanting to get people to build this into their application so that they can try and get off this this drug of using secrets. Because right now we want to get them out of the Stockholm syndrome and thinking about using workload identity instead of secrets.
Yeah, you've definitely conveyed that passion in this conversation, and I appreciate it. Before wrapping up, I've got to go back to something you mentioned earlier, your time selling books door to door. I saw somewhere that you did that in Montana. What were you up to there, and why Montana, of all places, the third least densely populated state in the U.S., and how did it factor into where you are today?
By the way, one of my favorite places in the U.S.
Yeah, it's gorgeous.
Honestly, what a great state Montana is. It's a big sky country. What a place. And it's been obviously quite well advertised recently with the series of Yellowstone.
Yellowstone, yeah.
But not many people knew about it before, but the park and Glacier National Park is absolutely incredible, by the way. So massive fan of Montana if anyone wants to take a trip up there. But I was a student at university in St Andrews in Scotland, and I heard about this crazy exchange student trip where you would get trained how to sell door to door. And they would then send you to various different locations around the country, and your summers would be spent knocking on doors, trying to sell books.
Mm-hmm.
And essentially, I was transported to Montana. I was given a town to go and, I guess, live in. You had to find your own place to live. So I actually had to knock on doors, and I found the first place to live by knocking on a door. And then essentially, you would start your day. you would knock on doors from about 8 a.m. till 8 p.m. at night. And you would essentially try and sell your books, take the deposits, and then you would use the deposits for living money. And it was like playing a video game, because you'd take the deposits and then you'd have a bit more money for food. So I could upgrade my ramen noodles to like ramen noodles with salami in it. And then after about a month or so, I'd had enough money to buy a car. So that enabled me then to get out into the countryside and start selling to the countryside. So it was kind of like this series of steps you had to go through. So essentially it was like running your own business from scratch.
Right.
And I did that for 3 summers.
Mm-hmm.
But sales and that sort of rigor that goes into kind of getting up day in, day out and sort of trying to demo books for like 10 hours a day and understand objections and understand how to get inside the doors and sit down and actually have that conversation with people, how to get over the various different objections and issues and understand how to close was foundational, honestly, to my career. And so I think a lot of what I did was just take a lot of those principles that I learned selling books and then apply them to selling software, honestly.
Any great tips on getting bugs off of windshields?
Bugs off windshields?
Yeah.
It wasn't bugs that I had a problem with. Actually, obviously in Montana, there are a lot of animals, wild animals and roadkill. So it was more avoiding the deer.
So I guess to wrap things up for this particular episode, and thank you so much for everything. What's one piece of advice you'd give to CISOs and other security leaders who are grappling with the challenges of securing machine identities?
Yeah.
Are you interested in buying an educational book today? Is that the right approach? Did I do that right?
You did it. You did all right, actually. Yeah.
All right. Do you have to stand like 3 steps in front of the door?
I'm trying to think whether I'd be able to sell a book to you at this point. Like, how would you respond if I knocked on your door? Do you have one of those signs that says no soliciting outside? I used to hate looking at seeing those.
No signs. And I think one time I did a training to sell frozen seafood.
Okay.
But it involved a lot of like where you're supposed to stand and, you know, how you get your foot in the door and all that. And it was, and I think luckily I got a house painting job the week later and didn't have to do it.
I used to have to compete against the Cutco guys,
okay.
Knives.
Yeah.
And then the frozen seafood or meat. I can't remember what that was called.
Right.
Yeah. So one piece of advice, I'd say what I'm seeing a lot of organizations do that I think is really working is that they're creating a workload identity working group of like the key people across the organization. Platform engineering, so the people running the cloud native platforms, identity people, identity and access management people, security architects, and they're creating this working group. And essentially what they're doing is they're going through those steps that I talked to you about before. They're doing the discovery of the workloads and workload entities. They're doing the context of those. And then they're like, okay, that's going to take us part of the way. But then let's now think a step further of how we go past this and do something better than what we did before. And so I guess that it probably boils down to create a workload identity working group. Go and explore all of that world of NHI discovery. Go and explore that world of SPIFFE and just start to think about what that strategy might look like over the next few years. The great thing about SPIFFE is that it's open source. It's part of the CNCF. There's lots of working groups. The book is open source. I think it's at spiffe.io. We do an event, the day 0, which is every time KubeCon's on, we do that. So the next one is in Atlanta on the 10th of November, where we'll have Uber and Square Block talking about their adoption of SPIFFE and how they use it at scale, specifically to tackle some of the problems that we've talked about on this podcast.
And soon thereafter, those folks, or before perhaps, we'll hear from those folks on the Security Matters podcast.
Yeah.
Can we break that here?
I hope so. I will. Well, I haven't asked them yet, but I'll go and twist their arm and I'll make sure they do it. So yeah, if they're listening to this, then you better do it.
We would appreciate that.
Yeah. And so I think it's a workload identity working group is a really good start. If you don't think it's that important enough to set up a working group like that, then I think you're going to be convinced in the next 6 months to a year as we start to see the fallout from the AI agent thing, I believe. So I would say get ahead of the curve, do it now. It's definitely going to be a longer process, but it's something that we're going to need to start tackling now so that we're ready for the swarms of AI agents that are going to come over the next 5 years.
Day 0 in Atlanta in November. Matt Barker, thank you so much for coming onto the podcast. This has been really great.
Thank you so much for having me and letting me talk to my heart's content about workload identity.
All right, there you have it. Thanks for listening to Security Matters. If you like this episode, please follow us wherever you do your podcast thing so you can catch new episodes as they drop. And if you feel so inclined, please leave us a review. We'd appreciate it very much, and so will the algorithmic wins. What else? Drop us a line with questions, comments, and if you're a cybersecurity professional and you have an idea for an episode, drop us a line. Our email address is securitymatterspodcast, all one word, @cyberark.com. We hope to see you next time.